Hello everyone, so my name is Paul King and I work in the construction team at Bentley Systems. So this session is about using digital technology to deliver better infrastructure projects. And if you follow construction news sources, then I'm sure you've seen many examples, as we have today during the sessions, of how technology is being used on projects. And I'm going to explain some of the technologies like 4D construction, digital twins, and reality modeling. And I'll show an example of how digital twins are helping firms to win projects, deliver them more efficiently, and improve their profitability. And when I talk about infrastructure projects, I really do mean every type of infrastructure and through the entire project lifecycle, from planning, design, through construction, and onto asset operations. And today, I'm focusing very much on construction. Now, building any type of asset is complicated. As you can see, when you look at what's needed to deliver a new railway project, for example, we don't just design the railway and then go and build it. Software plays a really important part in planning, designing, analyzing, constructing, and then managing the asset. And the activities on this screen are complicated enough on their own, and they're often performed by different organizations in different countries using different software. And the construction team on site then has to make use of all this data and information and deliver the railway on time and within budget. And that budget, of course, is usually set by a competitive tender process. So every dollar really makes a difference. Now, these are some of the typical technologies that you'll see being used on projects, everything from 2D up to mixed reality. And it's important to keep 2D on the list because many parts of the industry still don't do 2D very well. And I've highlighted 4D planning to show the benefit that even simple advancements can bring. Ryan in the US saves 4 weeks off the schedule for every 8 months of construction when they use a 4D process. Now, should you be doing all of these? Probably not, but you should be thinking about when and how you'll get started. And also ask yourself, what are your competitors doing? In my experience, successful projects ensure they get the basics right, and they spend time and effort implementing best practice. And there's currently a lot of interest and activity around digital twins, but it's not really something you can just turn off or on when you need it. Digital twins offer huge potential to improve project delivery, but they build on existing best practices, and you have to get the basics right. So it starts with creating high quality components. And creating components means vertical and linear assets, as with this railway example. And the industry now has access to the latest design and BIM technology, some of which we've seen today. And it's really important to get the design right. And it has to be complete, consistent, and correct. Next, best practice workflows ensure that your data is managed securely and effectively. A common data environment, or a CDE, supports a robust BIM process. And a CDE is actually a simple principle. It stores and manages content created by the team, and it delivers that to the right people in the right format at the right time for the task. And the recent ISO standard means there's no longer an excuse for not using best practice collaboration on projects. So moving on to context. Surveying technology means that it's easy to place and review components in their correct context. In this example, we're inspecting a rusted column, and we've taken a series of photos on a phone. The Context Capture Cloud service converts them into an accurate 3D model that I can look at on my phone, and I can share it with other team members. Or I could use it to model the excavation of underground services on site. And again, I can share that with the engineer back in the office. Of course, most projects have data in different formats from different sources. And so it's important to consider the alignment, the accountability, and the accessibility of data. Data alignment ensures that you can take design information from different software and reuse it. Data accountability means that you know who created the information and what it can be used for. And data accessibility ensures that your construction teams can get the information they need by using their preferred device wherever they are. And in Bentley, we've developed an open source way of doing this called iTwins. Now, when you have the components and the workflows and the context, then you have the basis for a construction digital twin. And the simplest definition is that it's a representation or digital representation of a physical asset, process, or system. But a twin's a living thing, so it has to be continuously synchronized. And it should use data-driven workflows to optimize performance. And from a technology perspective, digital twins are being enabled by advances in areas such as reality modeling, artificial intelligence, mixed reality, and machine learning. And more of this technology is becoming available every day, and it's getting a lot cheaper. And the construction digital twin involves inputs of data, such as design data, that could be drawings and models, pre-construction information, and feeds from the field. And it uses these inputs to support construction workflows like 4D planning, model-based estimating, and machine automation. And the result is a jump in productivity. And I'll show you an example of a construction digital twin where 4D planning was used. So just one small area, but it had huge benefits. So this is the One Za'abil mixed-use project, and it's a new landmark building for Dubai. So it's an example of a project that used 4D construction modeling to improve the project delivery process. And it impressed the judges to become a finalist at Bentley's 2019 Year in Infrastructure Awards. The two towers are linked by a steel bridge, and it includes the world's largest cantilever. It extends about 66 meters. The link itself is 227 meters long, and it weighs 8,500 tons. And in fact, the steel structure weighs more than the iron in the Eiffel Tower. And because of the size and complexity of the project, the main contractor, Alec Engineering and Contracting, embraced 4D construction modeling. Now, at the end of last year, 4D modeling had taken 70 days off the program, thanks to clash detection and better planning. And the project had saved $16 million by giving clearer visibility into the structure and the schedule. And in the early project stages, the team had used traditional tools for looking at different ways of building the structure, for anticipating the risks, and understanding the sequence of construction. But they realized it would be much more efficient to communicate using 3D and 4D models. Now, by using 4D modeling early in the project, they detected clashes that would otherwise have been really expensive to fix. And importantly, these weren't design clashes. They were clashes in site operations and construction logistics. And those things are really hard to detect during design. And 4D modeling also identified other opportunities to save time and money. One example found a clash between a crane on one of the towers and the steel bridge. The planned location of the openings in the structure for the crane, for the supports of the crane, didn't allow the tower crane to jump up before the bridge was installed. Now, if that clash had happened during construction, it would have delayed the erection of the bridge. And because the bridge was on the critical path, the whole project could have been late. So 4D modeling was used to plan how to avoid the delay. The crane opening was shifted, and the crane was planned to jump on an earlier date. So that one item alone avoided a delay of 40 days and $12 million in costs. Another example involved the construction sequence of the bridge, which was configured in 6 parts instead of 7. Building it as 6 parts meant it cut out a sliding operation over the road. And that in itself saved 30 days and cut the costs by $4 million. And the model was also used by the project team to persuade the Dubai authorities that the link bridge could actually be lifted safely. So how can a construction digital twin help your project? Well, it provides real-time data visibility, and that means that everyone's on the same page all of the time. It provides 4D planning and 5D estimating, so that your resources are optimized and risks are reduced. And it provides operational efficiencies and business intelligence. And that means that teams make better decisions faster out on site. So construction is starting to shift in the right direction, and we're moving rapidly from the old ways of doing things to new ways. Construction software is now enabling project teams to define and implement best practice processes, and to do that consistently across every project. And it means that teams spend more time working on value-added tasks. And ultimately, construction technology is helping firms to win projects, deliver them more efficiently, and improve their profitability. Thank you.